equations were solved using either the addition or multiplication property of equality. Solving more complex equations will require the use of both properties of equality. So the other, from section 1, the homework was page 35, 1 through 33, homework 2.1. We also did go over some of the practice problems on page 34. These are simple algebraic questions. Now, some of these questions, you might say, x minus 8 equals 12. That's simple. I just add 8 to 12, I get 20. 20 minus 8 equals 12. You don't really need to know to add the same thing to both sides in order to get that answer. Okay? You almost could get it without doing anything. Okay? But the point that we're trying to learn is that what you do to one side of an equation, you have to do to the other. That's what keeps the equations balanced. And in the first section, we just did basically one-step algebra problems. This section, we're going to do two different things. And so we're going to follow the rules. It says here, page 36, I'm reading the paragraph there. And the reason I read from the book, and I'm doing this for the benefit of new people that might watch this video. The reason I read from the book is to show you that you can also read from the book. Okay? This is made for you. This is your level. Like if you were home and you didn't have a teacher and you had to learn this, you still could. Really, you could. You just read it. Follow the directions. Look at the examples. I'm here to kind of guide you. But the more you try to read the book, the more, you're going to learn comprehension skills. Like it's going to help increase your ability to follow directions. There's a lot of times when you do math class, the teacher tells you something to do and you're like a machine and you just do what the teacher says. And up to this point, maybe not with a lot of understanding. You just follow the procedure, follow the procedure, follow the procedure. But really, at this point, you should be learning why you do what you do and have more understanding of the process, okay? So that's why we talk a little more on this. Because in algebra, you learn the rules and then you apply it. You can apply it to fractions. You can apply it to decimal numbers. You can apply it to big numbers, small numbers. And they're all different. But you have to know the rules, okay? So in this equation, in the paragraph, it says 2x plus 3 equals 5. You can see in the side, we subtracted 3 from each side, and then we divided by 2 on each side, and we ended up with x equals 1. Now, when you get x equals a number, you plug that back in your original equation, and you see if you get a true statement. And if you do, then you got the right answer. Okay, so the rule is going to be in example 2.2, it says, simplify each side of the equation, isolate the variable term, and then you're going to first you're going to first add or subtract, then you're going to multiply or divide, and then you're going to check the solution. And that's going to be the same process for every single equation. Okay, so that's example 2.2. The rules are simplify each side. So if you have something you can put together that are real numbers that don't have letters, simplify. Add or subtract, multiply or divide, get a solution, check your answer. Okay, we're going to move on to it. Underneath on page 37, it says conditional equations. Every equation discussed so far has had a single solution. Equations that are true for some values of the variable but not others are called conditional equations. For example, the equation x plus 4 equals 12 is conditional because it's only true when x equals 8. Now, we will find when you just have an equal sign, there's only going to be one solution. But down the road, we're going to do a greater than sign. So then X could be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So X could be more than one thing. Or if we have a less than sign, X can be more than one thing. So if it can only be one thing or it only works for certain numbers, then it's called conditional. So that's just a vocabulary word that might not come up a lot, but make sure you know what it is. Identity. Not all equations are conditional. Identities are equations that are true no matter what value is substituted in. So look at this one. Anything I put in for X in underneath identity will work. Therefore, it's all solutions. It has infinitely many solutions. I can picture a quiz question right now. How many solutions do identity equations have? Infinitely many, if it's identity. Conditional has a set number, usually one. It could, there's some equations that will be more than one, which we will talk about some other time. Contradiction is if there is, what does it say? An equation that is always false no matter what value is substituted. For example, 2x plus 1 equals 2x plus 3 will never be true for any value that is substituted for x. And to determine if equation is contradiction, try to solve the equation for the variable. When a contradiction is simplified completely, the variable will vanish and the result will be a false statement. So 1 cannot be equal to -5, therefore it is a contradiction statement, okay? You can't, there's no solution. So these are words that will come up when we solve equations with 2 variables. Then we'll solve equations with 3 variables, and these still will apply, okay? So those are words you have to know. Then there's a little chart at the top of 38, which talks about, gives you those examples, okay? You have conditional, identity, and contradiction. So know what those are. So right now during class, I would like to go over a couple of these, and I will also have you guys come up and do a couple on your own. Okay, so what is the rule? We're gonna do number 1, -2x minus 3 equals 7. What is the first rule for solving equations? You can look in your book. Where the examples are, huh?
If the variable.
No, that's not the first rule. Number 1, simplify each side of the equation. Okay, so if there's anything that you can put together, now this one, I don't have any numbers I can put together. It's pretty simple, it's simplified. I don't have, but like say I had 7 times 3 here, I would do 7 times 3 first. So that's the first rule. Second rule, the overall rule is you want to isolate the x. Yes, that is your goal. Okay, you want to have x. Okay, I'm going to do a x equals something, and that is called isolate the variable. Okay, that's your overall goal, but then there's steps that we're going to take. So the second step is what? You can look in your book. At the example, look at the example. The yellow box, it gives you a little list of.
Isolate the variable time.
Number 1, simplify. Number 2, what?
Isolate the variable. That's what it says.
You weren't looking at what when I was explaining. Number 1, simplify. Number 2, okay. Yes, it does say isolate the variable, but it says subtract 3 from both sides. Okay, so this one says subtract, and this one says, okay, that one says subtract 2. So what I said when I was explaining it is add or subtract. Okay, so I'm going to shorten it. Yes, you're isolating the variable. The first thing you're going to do is add or subtract. You don't want to go right to multiplying. My third step is going to be multiply or divide. And then the fourth step is gonna be what? What does it say on that page?
Check the solution.
Check. Okay, so that's gonna be pretty standard. Like, you know, and the equations might get a little more complicated. But just keep those steps in mind. Your ultimate goal is to get x equals something, or y equals something, or whatever your letter is. Okay, so right here, I'm not gonna subtract, I'm going to add. Add what?
Add 3 to both sides.
All right, so this turns to 0. Next step,
3 divide
divide by,
-2.
and then x equals what?
-5.
-5. Okay, and then we're gonna check. -2 times -5 minus 3 equals 7. And it checks out. All right, so there we go. Who would like to do number 3 on the board? Number 3. All right, if you don't volunteer, I'm gonna choose someone. All right, I'm gonna choose. Okay, Henry, come on up. You knew it, right? You knew that was coming. Number 3, u over 5 plus 1, u over 5 plus 1, please write so we can tell what you're writing, equals 4. Okay? One of the things of algebra I will tell you right now is write your numbers clearly, because when we do get to a point where you have a lot of steps, if you can't read your own writing, that's frustrating, because then you have to go back and figure it out. So if you just write it neatly the first time, makes it nice, okay? So what did we do first? We subtracted 1 from each side. We got 0 here, 3 here. So now we have u divided by 5 equals 4. Don't really like your 4s. It kind of looks like a y. Like if we have a 4y, then how are we gonna know the difference? Okay. All right. So if I say u divided by 5, what would I do to make that 1 times u?
You have to make it this equal.
Yes. We say how do I get rid of the 5, but what we're doing is what can we change, what can we multiply by that 5 in the denominator to get 1? Anybody?
5.
5. Okay, so it's actually 1 over 5 times u, so I multiply both sides by 5. So if I do that, the 5's cancel, I get 1u equals what? I multiplied 5 by both sides.
Yeah.
20. Okay. So I actually multiplied by 5 on both sides. So I got u, and we don't usually write 1u. So even in our mind, we say, okay, that makes that 1. So it's u equals 20. Okay. So then you plug it back in. 20 divided by 5 plus 1 equals 4. 4 plus 1. How did this work out?
Test.
All right, so 3. Okay, so what did we do here? We got 3 and then you wrote 4. So there's our problem.
Here's all.
That should be a 3. And then 3 times 5 is 15. And then what did we do?
So that's gonna be a there.
This would be a what? Okay, so 15 divided by 5 is 3. 3 plus 1 is 4. So 4 equals 4. Okay. So if you plug it in, it doesn't work. There's a good example of just going back to your work. I know this is like, it's easy. Sometimes when it's too easy, then we make mistakes. And sometimes when it's really hard, you concentrate more and you might not make the same mistakes. Okay, Charles, come on up. Okay, you're gonna do number 5. 14 times 2, I'll call it out to you. 14 times 2 equals 3x plus 7. So the first step would be simplify. So what can you do simplify? 14 times 2 is, okay. 14 times 2 is 28. All right, and then we have, okay, subtract 7 from each side. 21. Okay, next step would be divide both sides by 3. And then x equals 7. Okay, now the next step is to do what? Check it. Okay, so you could just do 3, this is 28. 3 times 7 is 21 plus 7 is 28. 28 equals 28. Okay, so that does check out.
That is correct.
All right, number 7. This works. 5v
7.
5v minus 3v minus 5 equals 9.
Okay, so you,
5v minus 3v minus 5 equals 9. Okay, then 5v minus 3v is 2v, and add 5 to each side. You gotta write the 5, add 5 to each side. Okay. On each side of the equal sign. So then 2v equals 14, divide by 2, you get 7. Next step is doing what?
check it.
Check it, okay? So 5v would be 5 times 7. You can just write it, okay. 5 times 7 is 35. 3 times 7 is 21. Minus 5 equals 9.
That would be. Yes, this would become 14. That's not.
So 9 equals 9. Okay, so we got that. All right, very good. So now we're gonna try to share this whiteboard. Okay, so now we're gonna look at number 9. Number 9. 2 times 4x minus 3 equals 3 minus 17. All right, so who's left? Tyler. Gonna try this one. This way we can do it. And if you have to go up, don't know where my style.
Cool.
Okay.
Yeah.
You got it.
Okay, those of you who are just, I appreciate you paying attention. You can be writing it on your paper. See if you get the answer before the person who is doing it. You don't have to just copy it down as they do it. You can do it yourself and then see if you know if you get the right answer at the end. Okay, what are we doing? So 8x minus 6, okay, that's right. Minus or equals. Okay, everybody good with that? Add 6 to each side. All right, check again on that negative 14 plus 6. You can erase it, you guys get this thing right here. And erase it. I don't know how to, getting rid of that arrow is a little harder. Okay. X equals 1, is that what you guys got?
Oh, yeah.
X equals 1, that's not what I got.
I got negative. Guess I did it wrong. It's like 7.
What's missing?
Negative, the negative.
Negative, okay? So this should be -8 right here. -8, and then it would be -1 as an answer, and then you're gonna check your work. You have to go back to the original equation to check it though. So if you got just 1, if you can also turn it. This, yeah. We just did, we're gonna skip down to. 17. Okay, and those of you who are just writing x equals something, I really would prefer you to write out the problem. Okay, I want you to write it out with your own hand. Because that's how you learn. I know it's a lot of torture to keep things down, but trust me, it's for your benefit, okay? What am I gonna do here? What's my next step? Fiora, what do you think my next step is? This is number 17. I think you can talk. Can you talk? I don't know. My volume is turned up. My volume is turned up, so if you want to unmute and talk. Can you write on the screen? Okay. Well, all right. Go ahead. Keep going. So you added first, but the thing is you probably want to put together these two things first. So 5 minus 1, okay, so now you have 4/6 equals what? Okay, that works. Everybody good with that? So what's my next step? Multiply by what? Okay, so if I just multiply by, but I have to do it on both sides. Okay, Fiora, you can take it from there. I feel like it should come out even. Okay, so x equals it comes out to what'd you get? Oh, okay, so, oh, I see what you're doing. You could just, divide that out. 54 over 2, which is equal to 27. Okay, it does work out. So it's you can do your cross canceling and come out with the number without multiplying big numbers. So 6 over 4 would be 3 over 2. Then you could cross cancel with 18 and 2 and get 9 times 3 is 27. Okay, and then you check that by plugging that back in. So let's check that one out. Because it does seem like a weird number. Times 27 minus 1 over 6 times 27 equals, or minus 8. Minus 8 equals 10. Too much talking over there. So that would be 4 over 6 times 27 minus 8 equals 10. So I can do like cross cancel this, 2 over 3. 3 and 27 is 9. So 18 minus 8 equals 10. 10 equals 10. So it does check out. So that's an example of the numbers are a little weird. They don't work out as, it's not as easy to just look at it and figure out what the answer is. But you just keep going, following the rules. All right, I'm going to move on to identify each equation as conditional, contradiction, or identity. Number 22, what do you think? Number 22, is it conditional? Is it contradiction? What did I say? Did I say the right word? Contradiction, identity.
It's a contradiction.
This one is not a contradiction. You kind of have to do it out. You have to go 4x minus 8 equals 2x minus 2. Then you have to add 8 to each. Oh, man. So 4x minus 2 is 2x. Add 8 to each side, you get positive 6. X equals 3. So you get one answer. So it's what? Conditional. One answer is conditional. 23. You have it again. 6x plus 24 equals 6x plus 18. What can I multiply by? If I subtract 6x from each side, I get 0. And is 24, can 24 be 18? No. So it's what? Right. There's no solution, so it's contradiction. Okay, how about 25? What is happening? Did I say something? Maybe I said. All right, 4x minus 2x plus minus 8 equals 2x minus 2 minus 6. So 2x minus 8 equals 2x minus 8. So what's going to be the answer on that?
Oh, it's,
Identity, because anything I put in for x is going to work. All right, so that's what we're going to do on that. All right, so for homework, I would like you to do, we have 23 questions, page 39. Okay, I'm going to ask you to do, 2 through 22 evens for homework. That means it's only 11 questions, So that means make sure you get them right. Okay, 11 questions.
It's divided. This class is out.
Yeah, plus we have people online, so. Okay, any questions? So we're doing page 39. Algebra 1, page 39, 1 through 22, or actually 2 through 22, evens. So that's like your official homework. So hopefully you paid attention, you know what you're doing, and it won't take too long. It's only 11 questions. Please ask questions as needed.
Let's do the homework section.
I just wrote on the board what I want you to do.
Okay.
That's what I want you to do. Okay, if you want to do more questions, feel free to do more questions. The more you do, the more you're gonna learn. But that's what's required. All right, so those of you who are online, do you have any questions? Okay, so those of you who are online, I'm gonna sign off for now, and you can bring that in tomorrow. And we will talk about it during class, okay? I'll see you tomorrow.